Welcome to the deep dive. Today we're jumping right into the really impactful stuff happening in AI. We're focusing on the hot news that just dropped around August 23rd, 2025. There's this fascinating trend, towards models that are more specialized, more efficient, and maybe even more accessible. And it really starts with these models designed for very specific jobs.
That's exactly right. And our mission today really is to sift through all the noise, all the announcements. We want to pull out the key bits of knowledge, the insights from this constant stream of AI progress. It's about connecting the dots, understanding the why behind it all, so you leave this deep dive really knowing what's shaping AI right now.
Okay, so first up, let's talk about the enterprise space. Cohere's commander reasoning model. This one's making some serious waves, particularly for businesses. They released it with open weights, which is great for researchers, private deployments. But it's important to note, commercial use, that still needs a Cohere license.
Yeah, and what's really compelling about Commander Reasoning is that laser focus on the enterprise. It performs really well in agentic benchmarks, multilingual stuff too. And just quickly, agentic means these models aren't just answering questions, right? They're built to reason, plan, use tools, take actions over multiple steps, all on their own.
Right, powerful for those complex business workflows.
Exactly. And this model seems to strike a good balance between being safe and actually being useful. It cuts down on those over refusals where the AI just says, I can't do that too often. That's critical for business apps. Plus, the performance footprint is pretty impressive. It can run on just one H100 or A100 GPU.
Just one.
Yeah, with 128K context length. And it can scale up to 256K if you use multiple GPUs.
That's serious power from a single card. But one feature really jumped out at me, the token budget setting. This sounds like it gives users direct control over compute use and, maybe more importantly, cost. How much does that change things, compared to the old way of having separate models for reasoning and non-reasoning tasks?
Oh, it's a big deal. This token budget thing, it really streamlines operations. It's actually a core part of North, which is Cohere's secure platform for building these custom AI agents. It basically means you can often get the best of both worlds in just one model. Makes deployment much simpler. So a single model can kind of flex its resource use and your costs depending on how complex the query is, instead of needing two different models, which is often less efficient.
Okay, that makes sense.
Now, just a quick heads up, there were some user reports, about intermittent citation issues. With an older version, Command Azoo 3 2025. Cohere's advice is pretty clear. Use the new Commander reasoning. That one guarantees citations and should give more reliable results.
Good to know. And that focus on agentic use, it definitely seems like a major trend right now. Speaking of specialized but still powerful approaches, DeepSeek v3.1. This one's got a really interesting think-non-think hybrid thing going on. This design, it feels like it adds a whole new layer for developers and users, doesn't it? What are the big opportunities here? Or maybe even challenges?
It absolutely does. Yeah, the hybrid design is quite smart. See, DeepSeek v3.1 is a large mixture of experts model and MoE. That means it has these specialized submodels, experts, that kind of switch on for different tasks, makes it super efficient for handling diverse problems because you don't load the whole massive thing every time.
Oh.
It's got 671 billion total parameters, but only about 37 billion active experts at any one time. They trained it on huge amounts of tokens for both 32K and 128K contexts, and it uses FP8.
FP8.
Yeah, 8-bit floating point precision. It's key for getting more speed and using less memory on the newest hardware without losing too much accuracy. And the split is clear. Thinking mode for deep problem solving, non-thinking mode for simpler stuff like tool use or function calls. And they've added a new search agent ability too, which makes it better for complex info retrieval.
Right, and the community feedback seems, interesting. We're hearing it performs really strongly on coding benchmarks like SWE-Bench Verified.
Yeah.
The score jumped way up from 44.6% to 66%. Some users are even saying its coding is almost Sonnet level.
High praise.
Yeah. But then, on the other side, some folks find its general abilities, like creative writing or role play, are slightly worse than Gemini 2.5 Pro. So, kind of a mixed bag for general stuff, but clearly a coding powerhouse. Why is it getting integrated so quickly then?
Well, that mixed reception kind of proves its specialized nature, right? It's built for heavy lifting in certain areas, but the ecosystem integration has been incredibly fast. You've got Hugging Face weights out already, Intel's done INT4 quantization, and crucially, Anthropic API compatibility.
Ah, that's the key.
That's huge, yeah, because any application already built to work with Claude's API could potentially just swap in DeepSeek as the backend. That offers a potentially much cheaper alternative for companies already invested in that whole ecosystem. We're also expecting DeepSeek to adjust their API pricing soon, and everyone's kind of waiting for a free public release, maybe in September.
Okay, fascinating stuff. Moving on from these hybrid models, let's talk about ByteDance. They sort of quietly dropped a new model, Seed OSS 36B. Seems like it offers a different take, especially on data purity. What makes this one stand out? It's got this huge native 512K context window, and it was trained on 12 trillion tokens without synthetic data. That seems important.
Oh, the sans synthetic data part. Yeah, that's very significant. It basically makes Seed OSS 36B a really clean base model, especially for tuners, researchers who want to do specific experiments or build niche apps. The reason is synthetic data, while it helps scale training, can sometimes bake in weird biases or, hallucination patterns that are hard to get rid of later.
Right.
So Seed OSS offers a more, let's say, predictable and robust foundation if you're doing sensitive work or need really high accuracy where data integrity is paramount. Its architecture is described as pretty vanilla, no complex stuff like MHLA or MOE, which actually has some researchers hoping ByteDance releases a detailed technical paper.
Like they want to look under the hood of a classic car.
Kind of, yeah. To really dig into the fundamentals. And what's really impressive is the reported long context performance. It apparently scored 94 on the Ruler benchmark at 128K context. And people are saying it delivers long, coherent generations without refusal, even outperforming some competitors.
A strong claim for long context. Now, Seed OSS also has this unique thinking budget mechanism. He said it involves the model managing its own processing. How does that actually work, and what does it mean for prompting?
It's a pretty novel approach. The model uses these self-reflection markers internally. It tracks tokens it's used and how many are left in its budget. That tracking then guides its reasoning process. The recommendation is to set the budget in multiples of 512, or just set it to 0 if you want a direct non-reasoning answer. So it gives you, the user, this fine-grained control over how much thought the model puts in, which directly impacts speed and cost.
Interesting control mechanism.
Yeah. And just on a related ByteDance note, their seed prover actually got a silver medal at the International Mathematical Olympiad, IMO 2025, which is impressive, but it also raises that interesting question. How does success in formal math competitions translate to solving complex, messy, real-world math problems? Still an open question, really.
Definitely something to watch.
Right.
Okay, let's shift to the big players. Google Gemini. They've made some incredible strides in efficiency. And it's not just about speed, is it? It's about like a massive reduction in energy use and carbon footprint for running Gemini.
Yeah.
What does this signal for the sustainability of AI at scale?
You're absolutely right. The numbers are quite striking. Median text prompt in Gemini apps now apparently uses about 0.24 watt-hours of energy and 0.26 milliliters of water. Tiny amounts. But the real story is the year-over-year change. From May 2024 to May 2025, energy per prompt dropped 33 times. 33 times lower. And the carbon footprint, down by a factor of 44. It's like swapping a fleet of gas guzzlers for electric bikes overnight. It's a huge shift environmentally. And it's not just one thing. It's a mix of better models, more efficient systems, and strategically using cleaner energy sources in their data centers.
That's incredible progress. So beyond just being greener, what new capabilities are these efficiency gains actually unlocking for, users or developers? How does it show up in features?
Well, these efficiencies are basically enabling them to roll out more advanced features more broadly. The agentic AI mode in search is expanding a lot. It can now handle multi-step tasks, like actually making real-time restaurant reservations across different websites. It's also giving more personalized results and can maintain context across a session, and that's rolling out to over 180 countries.
Wow.
We're also seeing wider access to VO3 for video generation. Google even put out a Next.js template so developers can build an AI video studio right in the browser. And for government folks, there's the secure Gemini for Government platform, offering, they say, virtually no cost access for eligible U.S. federal employees.
So lots of expansion. Any downsides or bumps in the road?
Well, yeah, it's important to mention user feedback. There have been reports of massive banning outbreaks, which sounds disruptive, and some users have flagged issues with how image tokens are handled in prompts, and also with compatibility with the OpenAI standard for tool calls. So, still some wrinkles to iron out.
Always something. Okay, finally, let's get down to the metal, the foundational muscle behind all this, the GPU hardware landscape. We keep hearing about these absolutely massive training runs, right? But are they always as efficient as they sound? What's the real story in these frontier AI labs?
Yeah, it's fascinating, actually. You hear about these huge 100,000 H100 training runs from some labs. Sounds impressive, but the reality is many of them experience what's called under-delivery. Basically, software issues and system bottlenecks mean they aren't actually using those thousands of GPUs as efficiently as they could be. A lot of potential is just wasted.
So throwing more GPUs at the problem isn't always the answer.
Not always, no. Contrast that with DeepSeek's training run for V3.1. They used only about 2,000 GPUs, but reportedly got really strong results.
Oh.
Through really aggressive low-level software optimizations, it just goes to show that sometimes, software maturity and clever engineering can actually beat having a bigger fleet of raw hardware.
That's a great point. Optimization versus brute force. But what about the rest of us? People building AI at home or in smaller labs. We saw that pretty cool setup from PewDiePie, right? 160 gigabytes of VRAM. What's the reality for local AI development these days?
Yeah, PewDiePie set up 8 RTX 4000 class GPUs, 20 GZs, about 160 GGB total. It's pretty ingenious. It shows you can run something quite large like Llama 370B if you use low-bit quantization. That's a technique to shrink the model's weights down, basically, so it fits and runs on consumer-ish hardware. It really highlights the creativity in the local inference scene.
But it still has limits.
Oh, yeah. It also shows the limits, right? For the really huge multimodal models, you need way, way more VRAM, hundreds, maybe terabytes. For the really high end, you're looking at purpose-built workstations, like that A16's Founders Edition 1.4 RTX 6000 Blackwell Max-Q GPUs giving, 384 GB of VRAM.
Okay, serious hardware. What about Apple?
Apple Silicon's interesting, too. The M4 Max using MLX, which is Apple's own framework, is apparently outperforming GGUF running on the CPU for models like GPTOS S20B, both faster and more power efficient. GGUF is that popular format for running models locally, often on the CPU, and now you can even scale inference across multiple Apple devices using Thunderbolt 5. Pretty neat.
And this AI boom. It seems like it's even hitting the used hardware market, making older cards valuable again.
It absolutely is. AI hobbyists are snapping up older data center GPUs with lots of VRAM. Like the NVIDIA Tesla P40, 24 GB now goes for around $300. There are other options, like the NVIDIA V100 SXM2, maybe $100 for 16 GB or $400 for the 32 GB version. But you got to be careful. You'll likely need special adapters, serious cooling, and you might run into issues where future CUDA versions drop support for these older cards.
Buyer beware then.
Definitely. The AMD MI50 32GB is another budget choice that works with llama.cpp. People say the prefill speed is slow, but apparently it scales really well, linearly, for mixture of experts models. That's a plus for certain architectures. And then there's the whole ongoing debate about the new RTX 5090 costing maybe $2,000, and people are frustrated NVIDIA still isn't including P2P or NVLink for direct GPU to GPU comms on consumer cards.
Yeah, that's crucial for multi-GPU setups.
Exactly. And all this competition, this optimization push, you see it reflected in things like the Terminal leaderboard, just intense work happening across MI300, B200, H100 GPUs.
Wow. What an incredible tour of the landscape today. We've gone from these specialized hybrid models, amazing efficiency gains in the cloud, all the way down to the nitty-gritty of the hardware, both new and old, that's powering local AI experiments. The pace is just unbelievable. The whole field is constantly shifting.
It really is. And all these advancements we've touched on, the hybrid approaches, the focus on energy efficiency, this incredibly diverse hardware scene, they are fundamentally reshaping how you can engage with AI, whether you're developing, researching, or maybe just really curious. But, as the options just keep multiplying, a key challenge really starts to emerge, doesn't it?
Yeah.
How do you tell the truly game-changing tools apart from the just, slightly better ones? And how do you make sure your own journey with AI is both efficient and actually impactful in this constant flood of innovation?
That is definitely a profound question to think about as we all navigate this exciting frontier. Thank you so much for joining us on this deep dive today. Keep exploring, keep learning, and we'll catch you next time on the Deep Dive.